So yeah, I work with Gassco, and we operate the Norwegian gas pipeline infrastructure, which is coming up on the screen here now. And this is today the largest integrated offshore energy system in the world. And Gassco is a state-owned company, so we do not own any natural gas, and we do not own any of the infrastructure. We make sure that it is operated safely on behalf of the owners, and we make sure that it is open access on behalf of the shippers of the gas. And we also are responsible for developing it so that it's fit for the future needs. So can this infrastructure be reused for CO2, for instance? Well, unfortunately, there is no easy yes or no answer to that, but I'll come back to that question later on. Now, it's not easy to predict the future. In these times, not even easy to predict 2 weeks ahead. But we know that the future, the generations will need energy, and we know that the climate challenge lies ahead of us. So in Gassco, we recognize the important role of natural gas in the energy system today, but we also embrace the transition to what comes next. And this is where CCS can play a key role. And we have quite a long history, almost as long as Shell, with CCS going back to 2006. And as you can see on this timeline, we've studied a number of different initiatives over the years based on mandates that has been given to us from the Department of Energy on a case-by-case basis. Now, personally, I had the pleasure of leading the technical work that we did in the Longship project in the early phases between 2014 and 2017. So back then we evaluated actually pipeline transport as well as ship transport at different pressures, and we arrived at ship transport at medium pressure, which is a concept that was then handed over to the Northern Lights venture, who refined it and built it into what it is today. So it was rewarding to see last year that they are now ready to receive CO2. But of course, the Northern Lights is just a starting point. If we are to decarbonize the European industry and reach the climate goals, we need to scale up significantly. And we see now that the industrial companies are actively building business cases around permanent storage on the Norwegian continental shelf. So if we go back to 2019, there was just the Aurora license, which is owned by Northern Lights. And this was still the case in 2021. But now, since 2021, 13 licenses have been awarded, and there are more that are planned to be awarded in the near future. The stakeholder landscape is also quite impressive, with 13 companies that are developing CO2 storage in different partnerships and constellations. In parallel to this, there are several large-scale infrastructure projects being developed. We have some, in addition to Northern Lights, we have some onshore hubs. Okay. On the west coast, we have large-scale ship initiatives with direct offshore injection, like the Stella Maris project. And we have two large-scale pipeline projects, the blue and the yellow one, which you can see here. So there's a lot happening at the moment. And in light of this development, the Department of Energy has seen the need for independent evaluation of CO2 transport. So Gassco have been given the task of assessing these projects from an early stage to ensure that we have a holistic approach. And this is what we call the architect mandate, which is something we also do for the natural gas system. And in this work, we will look at what does each project mean for the area development as well as for the NCS as a whole? Does it afford any, does it contribute with any synergies or flexibility that improves the business case? And we'll also look into what kind of setup do we need to build a robust large-scale transport infrastructure on the NCS? And how does that in turn impact the area developments as well as the individual projects? So we're trying to utilize the benefits of the different transport modes and support the industrial development and establishment of the CCS value chain and market. In addition to the architect role, we're also project manager for one of the large-scale pipeline projects, the CO2T project, which is studying large-scale pipeline transports from the northern part of Germany to several storages on the NCS. So this is in the order of 20 to 30 million tons per year. And we do this on behalf of 7 of the NCS licensees who are funding the project. So this follows the same principle as for natural gas. And as been discussed already many times, the main uncertainty that we see now is the business case. So our focus is to look at the factors that help mature the business case and mitigate the associated risk. We also have a strong collaboration with OGE, who are developing pipeline transport in Germany. And both projects are part of the EU to North Sea PCI. And we're planning startup in the early 2030s. So another priority we have, of course, is looking into technology gaps. Research and development has played an important role along the way, and it will be important also in the way forward. And there are many topics I could have talked about, but I promised I'd say something about the work we've done on requalification of existing pipelines. And I'll also touch upon the CO2 specification, which has already been mentioned quite a few times. So when we talk about requalification of the Norwegian gas pipeline system, we are talking about large-scale subsea pipelines, 30 to 42 inches in diameter, 500 to 600 kilometers long, high-pressure carbon steel pipelines, 150 to 200 bar. So requalification of these pipelines must be done on a case-by-case basis, and it's dependent on a number of factors. The most important one is the availability, which means is it needed for transport of gas and energy security. But in the event that it is not needed for gas transport, or that repurposing for CO2 offers greater long-term value, there are some other factors that need to be looked into. An important one is available technical information. That can be quite different depending on the age of the pipeline. Also, the operational history of the pipeline. What kind of loads has it seen during its lifetime, external and internal? And then we have, of course, what kind of operational conditions do we need according to the business case? What kind of pressure, what kind of flow rate? Are we talking dense phase or gas phase operation? And where is the location of the potential hub and offshore storage compared to the location of the pipeline? But of course, requalification of pipelines for CO2 offers many benefits. You have reduced environmental impact. You don't need to build a landfall in UNESCO areas like the northern part of Germany. It can reduce cost. It's an optimized use of a resource that is already there, and it could potentially mean that you could accelerate the implementation. So what we see is that from the pilot requalification that the potential capacity of these pipelines is quite high. It could be in the order of 30 to 40 million tons per year. But there are a number of factors. that still needs to be investigated before we can make a conclusion. Now I have 5 minutes left. And the most critical one is related to running ductile fracture, which means that you can flare the pipeline open, given that the force of the fluid within is greater than the ability of the pipeline to arrest a growing crack. It's like a sausage when you boil it. This might mean that we need to install crack arresters along the whole pipeline, and that would be really expensive and perhaps not technically feasible. So that needs to be clarified. But we are working on these issues that was identified in different JIPs and R&D projects. So, lastly, the CO2 specification, which is a bit of a puzzle. There are many drivers for the CO2 specification that are sort of impacting the potential limits of impurities. You have system integrity, you have flow assurance, you have HSE standards, but it also depends on the source of the CO2. Who are the emitters? What kind of transportation mode are we talking about? And are there any storage requirements from the storage sites? All these things can drive the impurity limits. And the main risk that is being discussed is related to the risk of corrosion, because we have a number of impurities such as H2S, SOx, and NOx in combination with water and oxygen. They can form what we call acid dropout, which is a liquid corrosive phase that can severely damage the infrastructure. But the discussion is not only technical, it's sort of strategic as well. And there are a number of dilemmas in this dialogue that we need to navigate. Most important one is perhaps safety versus cost. If you have a strict spec, you increase or decrease the safety risk, but you increase the cost, and vice versa. You have the purification point, which is being discussed. Where in the value chain should we purify? Should we do it at the capture site or somewhere else? And then you have data and knowledge sharing. Where on one hand, if we share data and knowledge, we can raise the knowledge level in the value chain and make better decisions. And on the other hand, you have commercially sensitive information, and not everyone are incentivized to share. And then you have setting of standards. Should we go for a streamlined, uniform standard now, which could increase cost of operations and make the process more streamlined? Or do we need flexibility now when the early projects are starting to account for things that we don't know right now? So it's a bit like this guy here standing over by the sign, trying to make sense of it all. And so lastly, are we on the way to reach the 2030 targets? That remains to be seen. I think we can say that the train has left the station, but we are laying some of the tracks as we go along. Thank you.